Okay, so this is the second part to 7.7. And what we're doing is we're continuing with the sum and difference identities. And so in the previous video, we proved sine of alpha plus beta equals to sine, cosine, cosine, sine. So that's how I memorize it: sine, cosine, cosine, sine. And then that's why my brain will get used to it. You do not need to memorize these because you have access to them. So let's move on. It says once you have an identity for sine of alpha plus beta, you can actually find the identity for sine alpha minus beta algebraically. Begin by noting that sine of alpha minus beta is equal to sine of alpha plus negative beta. Makes sense, right? And apply the identity you found in the problem 2 along with the identities you explored with sine of negative theta equals to negative sine theta, and cosine negative theta equals to cosine theta. So wait, what's the first thing that you want me to do, Miss Johnson? The very first thing that I want you to do, maybe I should write it over here because Miss Johnson, she writes so big. So the very first thing I'm going to write is sine of alpha minus beta is equal to sine of alpha plus negative beta. And I'm going to use this formula that we just got, the identity that we just proved over here, in order to build this here. So I'm going to use the sine, cosine, cosine, sine, except for in terms of, instead of beta right there, I'm going to put negative beta. Okay. So let's do that. So we get sine, cosine, plus cosine, sine. And then I will put alpha, and then I'll put beta, but now I'm going to put negative beta and negative beta. So all I did is I just used the definition of subtraction, which is adding the opposite for this first part. And now all I'm going to do is I am going to prove that this is correct, and then move on to the next step. So the next step they tell me to use is remembering that sine of negative theta equals to negative sine theta. So sine of negative theta, which is right here, that's sine of negative beta. So instead of that, I'm going to be writing negative sine beta. And I'm going to put it in parentheses because invisible here, there's an invisible times. I'm multiplying cosine alpha times sine negative beta. Okay. And then similarly, it says cosine of negative theta equals to cosine of cosine of negative theta is equal to cosine theta. So that I just need to, instead of writing cosine negative beta, I'm just going to be writing cosine of beta. Okay. And if you remember that identity, it makes sense because that is the definition of cosine being an even function, right? And then I'm just going to copy down exactly what I have here, which is sine alpha, cosine alpha, and then plus. And then I'm going to see if there's anything else I could simplify, which I can, because this right here says negative sine alpha times cosine alpha means that I can multiply a positive times a negative becomes a negative. So then this just becomes negative, and then the rest of this cosine alpha sine beta. Okay. And same goes here. This is sine alpha cosine beta. Okay. So then that is my identity of sine alpha minus beta. This is my identity right here. So I'm going to put it in a little green box. So there's my identity, and that's also what shows up on our trig sheet. So there's another one that we've been using. We've actually proven the addition and the subtraction one. So I'm going to go to my trig sheet over here, and in case you don't know where they are, they're right here. And it kind of looks funny because it says alpha plus or minus beta. When you're following this trig sheet, the top sign goes with the top sign and the bottom sign goes with the bottom sign. So now we know these ones and we can kind of highlight them. We're going to prove the rest of those, so then that's why I'm highlighting the rest of those today. So now we know sine of alpha minus beta. Sine of alpha minus beta is sine, cosine, cosine, sine. And then it's subtraction. I forgot parentheses right here, so I'm going to put parentheses right here. Okay. So let's do this next one. It says you can find the identity of cosine alpha plus beta in the diagram also, since OA is congruent to DC. So let's look at that. OA is congruent to DC, right? That's congruent to that. Okay. And you're like, okay, well, Miss Johnson, how's that help me? Well, we know that the top, like, since the whole thing down here, this green highlighted part here is cosine beta, cosine alpha, and we already know part of this, all we need to find is this last little piece. And if you look at this yellow, blue, green triangle guy, right, this yellow, oh, here's down here. We don't know this part here. This is the part where we didn't know. So if I was to continue this on, I can say that, oh, that's just cosine. So this is cosine of alpha plus beta. And I don't know this part right here. So that's going to be what I want to find out. Okay. And then that's going to be equal to, I don't know, whatever. What would I call that? I've used a lot of t. I haven't used t. So t over 1. So that length is just cosine alpha plus beta. So they said that that's congruent to that. So that actually means that this guy up here is cosine alpha plus beta. That little guy there, this little section here, let me make him, I don't know, great. This here, this section here is congruent to this section here. So now you can look at that equation. I don't know if you see this equation, because the top of that rectangle DC is congruent to the bottom of that rectangle OA, we actually have an equation. So let's write that equation out. I'm going to have to flip back and forth, so you'll have to forgive me. So the equation that we have is the bottom side, which is cosine beta, cosine alpha. So the equation that we have is cosine beta, cosine alpha. That's the bottom side, right? Is equal to cosine alpha plus beta plus sine beta sine alpha. Okay, I'm going to try to remember that. So this is equal to cosine of alpha plus beta plus, and then I don't remember what it was, sine beta sine alpha. Sine beta sine alpha. Okay, so then now what I'm wanting to do is I really want to go through and see if I can solve for cosine alpha plus beta, because that's what they're asking me to do over here. So, and you guys are like, oh, well, all you have to do is subtract from both sides, and then I get that cosine alpha plus beta by himself. Very good. So I'm just going to subtract sine beta sine alpha, sine beta sine alpha. So the way I write this, so for sine, I say sine, cosine, cosine, sine. For cosine, I say cosine, cosine minus sine, sine. So I go, let me move this over a little bit so that I have more room to write it. Okay, so this is going to be equal to cosine, cosine minus sine, sine. Okay, and then I'm just going to put alpha, beta again. Okay, so here I go with my alpha, beta, alpha, beta. Okay, so here's yet another one that we've learned. And we're all just building on these from each other. And then again, I could find cosine alpha minus beta by plugging in to the number 4, right? So I'm going to do that really quick. So cosine of alpha, I'm going to write that down. Cosine of alpha plus negative beta is equal to cosine, oops, that's not cosine. Cosine minus sine sine. And then I'm just going to plug in alpha and my negative beta. Okay. And then when I do that, I get cosine, cosine, sine, sine. And then when I simplify all of this, we remember that cosine of negative beta is just cosine of beta, right? We remember that. This is the same thing. Cosine negative beta and cosine beta are the same because cosine is an even function. As opposed to sine of negative beta is an odd function. So sine of negative beta will simplify to negative sine of beta. And then you know what's going to happen next, right? We're just going to multiply those out and then we're done. Minus sine of alpha. And so negative sine of alpha times negative sine beta turns into a positive. So here's your final one. So I write it as cosine plus sine sine. And so this is my answer for cosine of alpha minus beta. And then this is another identity that we can now hold as true. Okay. So as we do this next part, these are called double angle formulas. And you could see why it's called double angle formulas because it's 2 times something and 2 times something. So what I would like you to do is I would like you to try these. And then we will talk about them the next time I see you. So what I want you to try is use the sine of alpha plus beta to figure out this. And then use the cosine of alpha plus beta to figure out this. Okay. And then you'll see like, oh, that's what it simplifies to. And then you can check your answer by looking on our trig sheet. Okay. And then that's actually it for today. And then if you have any questions for me, please don't hesitate to ask. Thank you so much for listening. Have a great day.